Hello, everybody, and welcome. I'm going to give it just a couple more moments before we get started here to let people get in the room. All right, thank you all for joining. My name's Hannah Dubilius, and I'm with DOE, and I have the wonderful pleasure of working with the Better Buildings program and all of our partners in the Low Carbon Pilot. You are joining us today for the very last peer exchange of the Low Carbon Pilot, although there are always plenty of opportunities to continue to join us in webinars for the Better Climate Challenge and in Better Buildings in general. I know you all will do that. You are in the right place if you have come today to talk about using energy management and information systems for decarbonization. I do want to go over just a couple of our usual housekeeping items before we jump into the content. The first is that you might have noticed that you are in listen only mode, so you're not able to unmute yourself. But if you're having any IT issues, you can use the Q&A chat box that's at the bottom of your Zoom screen in order to touch base with us, and we'll do what we can to resolve those issues. We also will be recording this, and it will go on the Better Building Solution Center. So that's great news if you want to be able to reference this later or send it to a colleague. But it also means that questions or things that you might bring up at the end will also be recorded. Finally, I will say that we're going to use a separate system for our Q&A session, Slido, and I'll talk about that in just a moment. So again, the Q&A that's at the bottom of your Zoom screen is really just for tech questions. All right, now that our housekeeping items are out of the way, we can go to our next slide here. I'm very pleased to be joined today by Hannah Kramer and Nora Hart, both from Lawrence Berkeley National Lab. They're going to be talking about energy management information systems, but I also wanted to give a shout out to our colleague Elliot Crow, also at LBNL, who has worked maybe with some of you who are on the line through the energy management information systems. I'm going to switch over to EMIS now, EMIS tech team through Better Buildings. These, of course, also will be available to you after the webinar through that tech team. Next slide. We are going to be using a tool familiar to Better Buildings called Slido for the Q&A. So I'm going to say this really slowly because I would love if you could right now go and open up either on your mobile device or in another browser, slido.com. You're going to enter the event code LCP. So again, slido.com and enter the event code LCP. Anytime throughout the presentation today, you're welcome to put in those questions and it will populate for us and we'll get to the questions at the end. You also have the opportunity to vote for a question you like. So you can use the little thumbs up icon to move that question up our priority list so that we'll be sure to get to those ones first. I'm going to say it one more time to give you the opportunity to open up your another browser and go to slido.com and enter the event code Low Carbon Pilot. Excellent. And with that, I'm going to go ahead and turn it over to Hannah Kramer to kick us off and start digging into the content.
Thanks, Hannah D. Appreciate the intro. So what we're going to focus on today is a lot of you already know about energy management information systems, but we're going to do a quick refresher on the capabilities and then really focus in on the value streams in support of decarbonization. So we're going to dig into some of those different value streams, and please do enter questions into Slido ongoing. Nora Hart is going to be moderating those questions, and she can jump in and interrupt if there's a quick question during the presentation. Next slide. So the question, how does EMIS relate to decarbonization? In a nutshell, all the best equipment in the world still needs to be operated well. So we are getting better technologies. We're moving towards electrification and heat pumps and more advanced systems. And it actually underpins the need for even more focus on monitoring those systems, and EMIS is going to be even more essential to make sure it all works. So more is being asked of our buildings, and the system designs are more sophisticated. No longer is it going to be put in a boiler and just let it run. It's going to be like hybrid systems, making sure we're as electrified as possible, integration with storage, thermal storage, battery storage, and even connecting with the grid for buildings supplying grid services. So owners currently are already obviously making use of these technologies in lots of ways. I'm going to talk about just those basic ways that EMIS are used. But really what we're focusing on is how to lock in the investments that you've made in both all these retrofits that are going to be coming up in really a historical level of investment in our buildings, and the commissioning investments to make it all work. And we're going to talk a bit about demand flexibility and how EMIS relates. So this graphic on the right shows, just in kind of a nutshell, how analytics and control optimization, so that's that realm of EMIS, is kind of an overlay to building automation systems. In smaller buildings, that can start to blur the lines where the BAS is really integrated with the EMIS. So there's various layers of how much they're integrated. So we're going to talk about kind of the data inputs and what you do with that data. Next slide, please. But we all start with, in decarbonization, we're just going to take this lens of what we call this waterfall chart, where you always first look to avoid or use less, pivoting to low carbon solutions as secondary in terms of electrification and renewable energy. And then in the end, if you have leftover to get to net zero, there's other ways to deal with that. So I was actually talking about this graphic with my 14-year-old son yesterday on Take Your Child to Work Day. And I explained this all to him and said, you start out with energy efficiency, and then you electrify what's left and make sure you get rid of your natural gas, then you use renewables to support those systems. And he's like, well, why doesn't everybody just do this? This seems like logical and easy, and that just seems like a step-by-step approach. And I'm like, well, there is a cost component to this. And retrofits aren't as easy as new construction and so forth. But it was kind of refreshing, actually, to have someone looking at this new and saying, why don't we already do this? So that was my little anecdote about my 14-year-old son and teaching him about energy efficiency. Next slide, please. All right, so the energy management process with EMIS kind of looks like this, where we have data being collected from many sources, sensors, meters, pretty much more and more data. But what do we do with that data these days? The data is not very helpful if it's not analyzed and organized and value extracted from the data. So there's a data warehouse that integrates and organizes the data from disparate sources. And the analytics layer is really powerful to get value out of the data. So that analytics layer comes in a few types of flavors. Energy information systems are like the smart meter analytics and data visualization capabilities, which is actually shown here on this little example mobile device. And it really helps us know how much energy is being used at what times of the day and what systems, what parts of the building. Fault detection and diagnostics is another version of EMIS, a capability that provides insights into specific faults that are happening in the systems, and it generally uses the building automation system data to do that. And then finally, automated system optimization refers to kind of a more emerging capability of auto-correcting those faults. So for instance, the faults that are detected through an FDD system, you'll see implementation is outside of that realm. where the building engineer reviews and makes repairs, so that you sort of outside of the EMIS, you're making those repairs. We're starting to see technology and help develop technology that's bringing that inside the box of EMIS, where certain types of faults can be automatically corrected. And then EMIS definitely has the aspect of monitoring and tracking improvements and savings. It can be used for measurement and verification at the whole building level, so IPMVP option C, and help you automate that process so you can use that as a tool to see how well you're doing, to see if all those investments you're making persist. So let's go to the next slide where we're going to talk about a little bit more of the details. So this graphic, we're going to kind of walk through the 4 different types of EMIS capabilities, starting with monthly data analytics. Not all these capabilities are included in every EMIS, but there's more and more a single EMIS vendor. Their product may have multiple categories in integrating those together into a single platform. So we're going to look at these capabilities and show some examples on the right side in each of these 4 categories. So for monthly data analytics, you know, traditionally utility bill analysis has been done in various Excel sheets, and, you know, getting that data imported and analyzed may take months or more after that data is available. So this is all automated now. These graphs on the right show energy use over time in a annual basis, and then also in a monthly basis. The benchmarking process can be helpful, both benchmarking between your own buildings in your portfolio and then benchmarking outside. A lot of these monthly data analytics tools have automated Energy Star benchmarking, so you don't have to enter that data of your utility bills into Energy Star. It automatically ports that into it. So there's more and more integration happening, and this is kind of the biggest layer. It's mostly data visualization of your monthly utility bills. Next slide, please. All right, so now we're really trying to get, monthly data analytics is kind of the bread and butter of, you know, the basics. Now we want to get into interval meter data analytics. There's so much more you can see how your building's actually operating. You don't have to wait a month. You have hourly or more frequent data to do that. So, you know, interval meters, both at the whole building level and at system level, are used in EIS generally. These are some common plots that you can see. The heat map on the upper, the top version here shows you like your energy use intensity at different times of the day. You can look at that across the year and kind of get a picture of how you're doing. We hear a lot of operations folks really like looking at heat maps of various kinds. Load profile analysis, looking at over a course of a 24-hour period over multiple days, how are you operating, min, max, median, that kind of thing. And being able to filter and look at different things and all at your fingertips. No more wrestling with Excel to get the right data in the right format and spending half your time doing that versus analyzing it. And then there's a predictive process where you're looking at what is the prediction of energy use at every hour, and the tools automatically do this based on models. And you can see in this bottom graph how they apply that, where if your energy use, your actual energy use is less than your prediction or equal, then you're agreeing, you're doing good. But on a day where your actual energy use is greater than the prediction, so the prediction is in the color, you'll see a gap between those two, then your day is red. So you can start to see patterns like maybe Mondays are always kind of hard. Or Mondays or a holiday, you didn't turn down the systems or something like that. So you can program in different schedules as well. All right, so that's kind of a few examples of EIS. The capabilities are expanding all over the place in terms of the kind of measures you can see in interval meter data. All right, next slide. We're going to go on to fault detection and diagnostics. This is getting into the specific systems and faults and tracking persistence of measures. So there's a few ways to use FDD. At the top graph kind of shows that, like, this is an example of a screen you might see in a diagnostic screen in an FDD software, a supply damper control for all your different zones. Instead of getting little alerts and alarms zone by zone, you can just kind of look at it at one glance and see that you have one zone damper that's always open, you have one or two zone dampers that are always closed, and a few that are cycling. And you can say, okay, well, I'm going to focus my O&M staff on those zones and make sure that before I get my hot cold calls, I'm going to address those zones. So that's one way, sort of a diagnostic way to look at FDD. And then the other way is the identification of faults over a period of time, which is automatically done through the software. And the software generally also adds a component of how much how much cost, energy cost waste did that fault result in over that period of time. So this bottom chart shows, screen shows some suggested actions to excessive reheat. And, you know, honestly, these kinds of things, no one has time to sit there and look through their trend data, either real time or retroactively, and find, they could, if someone had time to do that, they would find tons of stuff. So the FDD system is finding it for you, but the trick of it is you got to fix it. So that's obviously always an issue with, if you have a lot of problems, do you have the staff available to fix those problems? So that's where the next phase kind of comes in with automated system optimization. On the next slide, where you're automatically optimizing in real time for many parameters, you're automatically correcting some of the faults that are able to be corrected. Of course, you can't automatically correct a broken damper because it's a mechanical problem, but you can automatically correct a control sequence that's really not working for the system at that point. So this is an example of a chillers and chilled water system optimization that is showing a user, you know, what kW per ton they're getting and how the optimization is helping them reduce their kW per ton. All right, so that was our overview of a refresher on EMIS. Next slide. I wanted to also mention that in the Smart Energy Analytics campaign, which concluded a couple of years ago, we really were able to do the cost benefit analysis and close the book on the cost effectiveness of these things, especially FDD. You see here, we had 9% savings, and both EIS and FDD had a payback of 2 years. EIS is generally less expensive to implement, less savings, less expensive, still had a good payback. So we were able to gather data from over 100 organizations of over 40 different EMIS vendors, over lots of different building types. And it became pretty clear to us that, you know, if you use these systems, it didn't matter which system really, it was how you used it and how integrated you had it with your O&M team. So anyway, in these reports, I'll show you on the next slide, if you go to the next slide, we were able to summarize all those cost benefit analysis in proving the business case for building analytics, which is on the left there. All these are available through the Smart Energy Analytics Campaign Toolkit on the Better Building Solutions Center. We did an EMIS applications showcase that Elliot Crow wrote, where that really pulled out kind of the best practices for folks early in their adoption of EMIS and folks in the innovation spectrum. We had an infographic that is good for kind of a one-pager to help give a sense of, you know, how EMIS work, which we've gone through so far. And then one of our most useful resources to folks was this specification and procurement support materials. So basically, it's an RFP template for an EMIS, and you're able to just, it kind of has anything you'd ever want in an EMIS in there, and you just cut out the stuff that you don't want. And you can use that language in your own RFP process. So people have been using that for a number of years. We updated it in 2020. Next slide, please. All right, so you have the bread and butter, make building systems more efficient, make sure they're going to stay efficient. So EMIS for efficient performance, but EMIS can also be used for demand flexible grid services. So this is kind of the next generation of what we're going to need out of buildings. With the needs for more renewable energy on the grid, there's need for more flexible use of energy at different times of the day. So the building automation system ensures efficient control with this analytics overlay. But now we're going to have automated response to grid signals. This is happening. This has been happening for 20 years, but it's going to be more important as more and more renewables get on the grid. So it's just another value stream that you can get out of EMIS. There's payments from utilities for participating in these demand flexible grid services programs, and it's going to be, getting ready to be a part of that is going to be lucrative for buildings. Next slide. So just sort of diving a little deeper in the type of, what does it mean to be a demand flexible building? Shedding and shifting load. So you shed load to reduce peak. There's this whole thing around the duck curve, and there's a lot of energy available during the sunny parts of the day. And then when people come home and turn on their lights and equipment and the sun goes down, there's a system peak. So that peak is moved later and later, and there are payments to reduce your peak load at that time. Shifting load to times when electrons are cleanest and most abundant. You can use thermal energy storage, you can use battery storage to shift that load. And this is something that, is going to be a revenue stream, because that time of use pricing is you're going to be able to shift consumption to the cheaper hours of the day. And pay that off-peak pricing rather than that on-peak pricing. This, not to mention reducing your demand charges in general, because you're limiting your peak demand, and mitigating your time of use rate increases as those time of use rates get more differentiated between the peak time and off peak. Having a demand flexible building is going to be to your advantage. All right, next slide. So now I'm going to just summarize kind of where we're at with thinking about EMIS value streams for decarbonization. So in the blue is kind of the value streams that we traditionally think about for just energy efficiency, what we've been doing for years with EMIS. And then in red, I added kind of how we're thinking about that decarbonization lens. So portfolio benchmarking, you prioritize your portfolio based on energy use intensity. Well, now you're going to start prioritizing your portfolio based on greenhouse gas emissions intensity. And asking your EMIS vendor if they can do those greenhouse gas conversions and what emissions factors that they allow use of, and if you have local emissions factors, those types of things are the conversations that people are going to start having with their EMIS provider. Energy use tracking obviously will morph into greenhouse gas monitoring, and including on-site renewables. There's just more layers to it now, and that additional complexity is going to be useful to have a single place to be able to look at that information. Identification of operational savings. Right now we look at energy cost savings as a metric in fault detection. Maybe eventually people will start to look at total emission reductions. and, creating projects that stack up and bundle to an overall emission reduction to achieve their portfolio goals. Persistence, we've talked about that, all this stuff needs to persist. You put in heat pumps, you need to make sure the savings persists and the emission reductions persist. Demand management, we talked about that briefly, shedding and shifting load and providing grid services. And one aspect that I didn't mention is just making sure your building can have flexible loads in a way that doesn't kind of backfire on you. So let's say you have a signal coming in saying reduce your peak, which automates a setting in your building automation system that reduces overall global temperature. So you have a global temperature reset. And I've seen this happen before where, that temperature on a warm day, let's say, is increased a few degrees. Well, in one case, they were doing a test of this. It's kind of a funny story. And the reheat turns on in the zones that had reheat at the zone level to reach that new set point. And that was like the exact wrong thing that they want. They don't want electric reheat turning on to meet a new global temperature reset. That's just setting a new peak. So making sure that your systems are working and having the data to be able to tell if they're working is really the thrust of a good EMIS that's going to support you in decarbonization. This last category is an emerging area. Coordinating and controlling on-site solar and storage, coordinating that with electric vehicle charging and your building load management. It's super complicated. And EMIS are at that level of supervisory monitoring and control. They're starting to get more and more abilities to do two-way control. So that's going to be the future for EMIS. I wouldn't say that many folks that we've seen are using it for that yet, but it's poised to be that interface, that single pane of glass to all your energy supply resources and your building loads. All right, so that's our summary for decarb. Next slide, please. I just have a couple more slides. I hope you're getting your questions into Slido so we can have a good discussion here afterwards. A little bit of a pivot to a couple of new resources that just came out in February from the Better Climate Challenge. You may have already heard about these two resources. One, a framework for greenhouse gas emission reduction planning. This is for portfolio level planning. So how are you going to decide how to prioritize all the things that need to happen to reduce emissions to achieve your portfolio level targets? This gives a framework for that. And then at a building level, what do we need to do to turn energy audits into emissions reduction audits? And we gathered input from working groups and from industry to come up with what are those additions. What does the whole package look like together of an emission reduction audit? And on that point, we're also coordinating with ASHRAE on how they're adding it into their ASHRAE 211 energy audit standards. All right, so those are two new resources. You'll have links in the follow-up email to those, or you can just look at Better Climate Challenge framework for greenhouse gas emission reduction planning, and you'll find all those. Next slide. This is the 5 milestones in the framework for emission reduction planning. I just wanted to flash those up here because this is sort of the organizing structure around the framework. We have a chapter on each of those milestones and examples within each chapter. So this is a planning process that once you start implementation of, executing your emission reduction plan, you really need that EMIS to help track where are you in your process? How are you getting those investments? Are they coming to fruition in terms of energy savings? All right, next slide. I think we're to the Q&A part. So Nora's, I don't even have Slido open. That's probably good. I'm not getting distracted by looking at Slido. Nora's been looking at Slido and she's going to manage the Q&A here.
Yeah, so I'll just give a quick introduction. So I'm Nora Hart. I am a technology researcher at Berkeley Lab, and I have been supporting EMIS research and also decarbonization research. So Hannah asked me to come here today and facilitate some of the Q&A that you all have had throughout the presentation. So I will kick this one off by asking you the question, Hannah, of who is typically using an EMIS and how often are they checking it? That one's got a couple of likes.
Yeah, that's a great question. Most often it's the energy manager or a facility manager. There's some champion that knows all the ins and outs. Maybe they're the super user, and they're looking at the data, they're flagging things, they're looking at the faults in the FDD system, and either those things can be automatically input into a maintenance management system, into work orders, so that the O&M team can then act upon those, or usually it's more, those are manually entered into the work order system. So I think it's kind of you might want everybody, like every operator, to have access to the FDD. And if they're really gung-ho and very tech savvy, they might love it. But generally, it's kind of a champion that's making sure that they're keeping on top of it and funneling the right issues to the right people over time.
Thanks, Hannah. So I think a follow-up question to that is, do EMIS work for smaller buildings, and is there a building size threshold? So to your point about having a champion and who does what, do you feel like that's different for a smaller building versus a large building?
It's definitely different for smaller buildings because they don't have that on-site champion in general that has that expertise to look at the system. However, EMIS is a perfect tool to be able to do remote O&M for many buildings. So a lot of times for small commercial, it's more of an instance of dozens or hundreds of buildings with a centralized operations center that's looking at all the data, even to the point of dispatching HVAC technicians to particular sites based on this data. It can be a way to streamline the way to serve those sites. I know some restaurants are looking at data around, not only their HVAC system and their temperatures and so forth to make sure their systems are running, but their refrigeration systems and even their cooking systems. So that's all centralized and can be monitored to avoid big problems. Like a refrigeration system that's maybe on the fritz, and you want to deal with it early in a set of convenience stores, let's say. So I don't think there's like a minimum size, although you wouldn't put an EMIS on a single 5,000 square foot building. You would have many out there, and then centralize your EMIS to cover a lot of them and have a person that's sort of on point for that.
Mm-hmm. Yeah, I think that makes sense. And someone asked a follow-up question that is related, and you touched on it a little bit, but they're asking, if you don't have a super user or an energy manager, do you have suggestions on how to make the case for establishing that position? And do we have cost savings estimates to help justify? And before you answer, actually, I do have kind of an anecdote from the Smarter Small Buildings campaign that we just kicked off. We have a participant, UC Davis, and they actually have their individual maintenance techs log into their EMIS. And so even if you don't have just that one super user, they've shown how to use it with a group of people, and you can just give access to the buildings that they work on. So it does work even if you have kind of a spread out maintenance team.
Yeah, and I know that especially when there are lots of buildings spread out, it's easier for them not to have to go to that building to find out what's going on. They can look at the data and assess whether they need to go out or even what equipment they need to bring with them when they go to that building. That might be, 5 miles, 20 miles away. So the question is, if you don't have a super user, how do you deal with it? How do you justify a super user? I think what we've shown in the data is that when you use EMIS, you get this value out of it. You get this savings. So you could apply those savings numbers to your portfolio level emissions, or sorry, energy use, and see what that cost savings looks like as an estimate. There are other business models, though, that I didn't really mention, that there's a gradation in terms of the EMIS vendors in how much of that support they provide directly as a part of their service. So they all provide the software as a service, but some provide that kind of day-to-day support in reviewing all the faults and helping sort of decide which ones are going to be the ones that are followed up on. They become more of an extension of your team. So that's one way to actually, without having to go through the process of, securing a open position and getting that filled through your organization, you can start with justifying it with using the vendor's capabilities in that space to provide that service. And then maybe eventually you can bring that in-house if it works out for the cost effectiveness equation.
Yes, that definitely makes sense. So kind of taking advantages of the services that the vendor offers, if you don't have the capacity, is another reason to install.
Mm-hmm.
Great. So a follow-on question is, do you have any tips on how to decide what type of EMIS is right for me?
Yeah, this question comes up a lot because there's all these different flavors and it can be pretty confusing out there. Everyone's trying to sell you their tool and you're trying to, I guess we could go back in terms of the slides to look at the slide with, it's the ASO slide. It has all the different capabilities on it. Jasmine, if you go back up. There we go. Yeah. So if you think about what are your biggest pain points, that's one way I've talked to folks about this, and who would use it. So let's say you have a really gung-ho energy manager that is trying to make sense of all the meters and works hard on using Excel and maybe even other tools that are more homegrown to make it usable and work to understand. They're starting to dabble in interval meter data, but mostly have monthly. I think, that is someone who could grow into be a super user of an EIS and get a lot more value and spend a lot less time gathering that data and making sure the data isn't bad and, all those things. On another hand, let's say you have a facility manager that has some problem areas of the building. They have a lot of hot and cold calls. They don't have the staff to do a lot of preventative maintenance. And they want to use technology to help them pinpoint the problems before they get the hot and cold calls. There's some really good case studies as a part of the Smart Energy Analytics campaign that we gathered around the decrease in hot and cold calls. So, saving time and making people happier by finding the issues before they became really big problems. So if that's your biggest pain point, you might want to focus on fault detection and diagnostics. Or you might want to do a tool that includes both EIS and FDD. More and more tools are having more, it used to be that it was really like certain vendors would focus on certain capabilities, and now it's kind of blending in so that more vendors have more capabilities. On the ASO side, generally that's a more emerging area. Currently, the most implemented types of systems for automated system optimization are for chilled water plants and coordination with air handlers. So it's like larger central plant systems that have the ability to tweak controls, variable flow, like changing the whole plant to variable flow plant is often a part of this process of being able to have those levers to do system optimization. So ASO is evolving, and it's an exciting area, actually, that LBNL is doing a lot of work in the automated fault correction area. So keep an eye out more. Actually, through these types of webinars, through the Better Buildings, we'll be sharing more about the automated fault correction research, I think.
Great. I think now we'll kind of shift to this next question, which brings us back to the high-level topic of decarbonization in EMIS. And so the question is, how do I change my EMIS to pivot from energy efficiency focus to a decarb focus?
Yeah, so if we go back to the 3 slides before, the summary slide, Jasmine, you know, a lot of the things are just using it how you've always used it, to identify operational savings, to do ongoing energy monitoring. And those things are going to help you find and fix measures and make sure they persist. So that's just sort of the basics. If you want to start talking with your EMIS vendor about integrating some of your data streams around greenhouse gas emissions, you know, greenhouse gas emissions are more than just your energy use. They're like your fleet energy use, your refrigerant leakage, that kind of thing. You could make EMIS your platform for gathering all that information instead of using like another platform for your greenhouse gas emissions reporting. That would be an emerging area of use for EMIS, but it kind of makes sense to have it all in one place. And if you know, the basics that are pretty easy are just add in those emissions factors and make those conversions from energy to emissions. So you can start to prioritize based on emissions and not just BTUs. So that would be sort of the first thing. And then ongoing, starting to add, like if you have battery storage system, being able to see the data from that on your EMIS dashboard, and you know, think about what are the things you need to monitor for that. Maybe you want to know the number of cycles on or off because it relates to your warranty for your battery. There's all sorts of things that we can start to think about in terms of integration into a centralized place, to avoid having to go into like 5 different systems to figure out what's going on with your building, and the time that goes along with that.
Yeah, that's a great answer. And it actually touches on one of the other questions that we have in Slido, which is what aspects of scope 1 and 2 emissions does an EMIS address? Are there any gaps in the abilities? And you kind of covered that a little bit by mentioning that you may have data on fleets, but you already said, hey, you could just pull that into your EMIS so you have it in one place. Is there anything else you want to add to address that question?
As we look more and more to overall emissions instead of just energy savings, I think it's important to get the realistic grid emissions factors in there. So your electrification projects can, you know, they're going to increase your electricity use, but what do they do to your greenhouse gas intensity? And making that the EMIS the place where you can be clear about how all these changes have impacted your overall greenhouse gas emissions, and like sort of a communication vehicle for how you're doing in your overall portfolio level greenhouse gas emissions reduction. People have goals, they have aggressive goals. Those goals are usually like the goals for the Better Climate Challenge are 50% reduction within 10 years in scope 1 and scope 2 emissions. I often wonder, you know, you can look at that data once a year as you gather up that information, you know, in your reporting, your annual reporting process. But is that going to let you have enough information to make different decisions? That's one data point every year. versus having that be a more ongoing tracking over time. That EMIS can really help transition from energy to greenhouse gas emissions and tracking. You know, it might not have to be at an hourly level. That might be overkill, but maybe at a monthly level that you know what your trajectory is, and not just be surprised when your annual numbers come out.
Yeah, I think you bring up a good point about visibility, because what I've seen in real estate is a lot of times the sustainability team who does the greenhouse gas emissions reporting is separate from the facility or energy team that's looking at their EMIS. So to your point, by having greenhouse gas emissions calculations in the EMIS, those people operating the buildings are more aware of their carbon footprint. And then maybe your building's really efficient, but you're using natural gas, right? And you weren't thinking about that before, but pulling in the greenhouse gases will help you see, okay, we're doing great as far as efficiency, but our scope 1 emissions are still really high for this building. So yeah, that makes a lot of sense for the visibility and looking at one platform.
I'm curious if anybody on this call has started to do that with their EMIS, started to look at greenhouse gas emissions intensity or tracking over time. You can put it in the Slido or in the chat if you want.
Yeah, I think that's a great question. I know it's definitely emerging. It's very common to only look at greenhouse gases once a year if you're submitting to CDP or some other reporting platform. I'm not seeing any responses in the chat now, so it may not be happening with this group. But I think that's fairly common, and it's definitely emerging in something new that people are looking to do. Okay, let's see. Any other questions coming in? So there's one question that we haven't covered yet, and it's about workforce requirements. So they say, are there any special workforce requirements for EMIS? How has this been accommodated?
Yeah, that's a good question. In terms of workforce and the training around utilizing these systems, there's, you know, some of the basics in terms of retrocommissioning and commissioning training is really applicable also to EMIS, because you're looking for those operational measures. EMIS just makes it easier to find them without having to find them yourself in the trends or by doing audits of the systems. So I think having that understanding of how systems work, you know, when does simultaneous heating and cooling happen, all that kind of stuff. There's lots of training out there on retrocommissioning, either through the commissioning provider training courses, like through the Building Commissioning Association or other associations, or also through the Building Operator Certification Group, that more and more, you know, operators are being asked to do more than turn the wrench. They're being asked to look at data. So how is that industry making that transition? I think the technology focus of building operation is, I mean, it's evolving fast. It has been for 20 years, and operators are going to need to be more savvy in how to use these types of software tools to optimize way more complex systems than used to be installed. So I think, you know, attention to training. If you get one of these vendors they do all the installation and so forth, but they also provide training to the operations team on how to use it, and probably a deeper level training also for that super user, to the one who's very involved in the day-to-day. One thing that's difficult is keeping that staff from, you know, having staff turnover and losing that expertise about your EMIS. So, I mean, that's a common problem in operations. People move around and so forth. So anyway, it's good to have a little bit of sort of cross-pollination, not just rely on one super user that if they leave, the whole thing kind of crumbles. And, you know, the EMIS vendors are really used to providing like ongoing types of training on the specific instance that they've installed.
Yeah, that makes a lot of sense. I think ongoing training is always important no matter what your organization is trying to accomplish. So it applies for EMIS as well. And it sounds like there's a lot of resources out there that people can use to stay up to date. So that's great. And at the moment, I don't see any more questions in the Slido, but I am going to pause for just a second to see if anyone else wants to throw anything in at the last minute. Give it just a couple seconds.
We can go to the next slide, Jasmine. All right. So a couple slides just to round out a little bit of information on the Better Buildings EMIS technology team. So you were invited to this webinar because you're either a part of the Low Carbon Pilot or the Better Climate Challenge. But we also have an EMIS technology team that meets quarterly or so, maybe a few times a year. That is where you would go for questions if you're a Better Buildings partner. You want to ask a specific question to one of our industry experts at Lawrence Berkeley National Lab. You can bring that question to the technology team. If you're not already on the EMIS tech team mailing list, just send a request to emis@lbl.gov. We don't spam a lot on this list. We send a few webinars, technical assistance opportunities, new resources that come out. Periodically, we're engaging less than quarterly with this tech team. But it is a useful way to feel connected to others who are kind of in the same boat of trying to make their EMIS integrated and work for them. So you have someone to talk to about that kind of thing. All right, next slide. I don't know, Hannah, if you want to talk about this one or you want me to cover this one.
I'm happy to jump in. Thanks. I was
Okay.
having a bit of some tech issues. Well, I'm very excited to invite you all to join us to continue this discussion and have some other ones at the Better Buildings Summit. At the Better Buildings Summit on April 11th, we're going to be having a workshop where you can come see Hannah, Nora, and I in person and talk about the greenhouse gas emissions reduction planning. Then that's a workshop, that's the first day. Then during Summit, we're also going to have 2 sessions I think will be relevant for this audience. One is also on emissions reduction planning, a framework for action, which is a really exciting new resource that we've put out recently. And then also a session on energy management information systems that Hannah will also be at. So you can ask some of your other questions in person. And finally, in June, we are planning a Better Buildings webinar, which is on greenhouse gas emissions reduction audits, a checklist for owners, which is a resource related to your emissions reduction planning. Next slide. So I hope you all will join us at Summit. It is in Washington, D.C., and it's just a couple of weeks from now. It's not too late to register, to book your information. I think that DC is a lovely place in springtime. You might just miss the cherry blossoms, but we'd love to have you for all of our many sessions and the peer networking opportunities that we have available. Next slide. So with that, thank you so much to Hannah, Kramer, and Nora for joining us and talking about energy management and information systems. I love seeing all those results from the Smart Energy Analytics campaign and just talking more about that shift from energy efficiency over decarbonization. So we appreciate your expertise and thanks for the great questions from our local carbon pilot partners. And I hope to see many of you in a few weeks.
Thanks all.